Hey, sixth grade. I wanted to make a video just explaining some of the questions from the recent science quiz. This will help you with your corrections and should help you when it's time to start studying for a Chapter 16 test in a few weeks from now. So I'm just going to go over some of the harder ones that you might have some questions about. Number 8, for instance. What happens when air reaches its dew point? From the dew point lab, we actually watched what happens when air reaches its dew point. We saw that condensation occurred on the outside of the can. So one option, one letter that I accepted for this question was A. We see the condensation happens, if we've got here's my wonderful drawing of a tin can, right? A tin can, the air around the tin can cools down. It cools down to its dew point, or where it will be 100% saturated, or where the relative humidity is 100%, also allowing option B. When that happens, dew forms on the outside of the can, like you see in this beautiful drawing over here on the right. So A or B was accepted. It is possible that the humidity will decrease. It depends afterwards on what happens, how much dew forms, if enough dew comes out of the air and therefore decreases the relative humidity, but that's not for sure. And D is possible if you're talking about air reaching its dew point up higher in the atmosphere where there's a big mass of air cooling down and forming a cloud. But since question 8 doesn't say when a large mass of air cools to its dew point higher up in the atmosphere, since it doesn't make that clarification and it's just talking in general about what happens to air when it reaches its dew point, A or B, it becomes 100% saturated, or relative humidity being 100%, and then condensation occurring. Since those both happen at pretty much exactly the same time, I will accept A or B. Another question was number 9. What kind of weather will nimbostratus clouds bring? A lot of people said D, thunderstorms, which is close but not totally correct. The answer is C. Remember, nimbostratus are stratus clouds are the low-lying wide clouds that bring, generally just light rain all the time when they are nimbostratus clouds. When they're stormy, they bring just light rain for the entire day. What you're thinking for the thunderstorms are the nimbocumulus, the ones that are flat on the bottom and big puffy clouds. Those will bring thunderstorms and big, lightning, thunder, lots of intense rain. But nimbostratus, that's just kind of if it's just a stratus cloud, it's just cloudy all day, gray outside. When it becomes a nimbostratus, it's just long periods of rain. Let's skip down to number 11. Please explain how clouds and then rain forms. Think through the whole process and start at the beginning. Drawing a diagram with labels, concepts, etc. is acceptable. 4 points. Now, one thing I wanted to point out was this 4-point thing. 4 points means that you should have at least 4 steps. Okay? During the quiz, I reiterated that this question is not asking about runoff and precipitation. It is not asking you to explain what rain is and the different types of precipitation. That word never shows up here. We're talking about formation of rain and formation of clouds. If you remember back to our 16.1 reading check, 2 of the questions were, how does rain form and how do clouds form? And when we were going over those reading checks, we were talking about the different words that should be used to talk about those 2 steps. Here I just put them into one question. So if we're going to look at how clouds form and then rain, since it's one and then the other, we need to start at the beginning. That would be starting with evaporation, right? The water needs to evaporate from the ground and get into the air for clouds to form. Then, once it's evaporated, that air containing the water can cool, to the dew point. When it cools to the dew point, it becomes 100% saturated. You could use either of those two words to get the point. 100% saturated. And it then forms condensation. That condensation then collects 100 times to form rain. So we've got 1 point, 2 points, 3 points, 4 points. So if you talked about it cooling, right, but didn't talk about the dew point, you usually got about half of those points. If you mentioned dew point or saturation and 100% saturation, that was fine. If you talked about the rain getting bigger or something like that, you got again half a point. But we want to talk about it collecting about 100 times. You could say 1,000. You could talk about collecting lots and lots of the little tiny droplets into one droplet of rain, right? Because it starts out as water vapor. It cools to the dew point and becomes liquid water, but tiny, tiny drops of liquid water. And those tiny drops then smash into each other and form one droplet of rain. So that has to happen millions and millions and millions of times for there to be millions of drops of rain. So then we have, when calculating relative humidity, what would happen if the air temperature went up? For some reason, I'm going to try to get some more space here. Keyboard, okay, so for some reason rain came down here. We know that's supposed to go up here. We can just, how about this? Let's do not form rain. Leave that there. So when calculating relative humidity, what would happen if the air temperature went up? Why is this the case? Again, 4 points. That should indicate to you that there's a lot to talk about here. This is a question that came off of the homework, right? For the homework from the back of the chapter. And we talked about this. We put these on the board, right? And we talked about, okay, so if one side of the equation goes up, if one side of the equation goes down, what's going to happen to relative humidity? So if I were answering this question, the very first thing that I would do is I would write the equation down for what relative humidity is, because we always talked about it as a math problem. So relative humidity is equal to the water present in the air currently over the max amount possible, aka determined by the temperature, right? Because remember, if the temperature goes up, the maximum amount possible goes up. And that gives us an idea for what the first option is. Remember, there are two, and that's how you get your full points. We talked about in class. Option A, if the temperature goes up, that means the denominator right here will also go up. So if the temperature increases, that means the denominator will also increase, which means the RH will go down. Because max possible goes up with temperature. More energy to hold water in the air, right? Now, there's also another option. And let's think about this. If the temperature goes up and the energy in the air goes up, that does mean that the denominator will go up, the maximum amount possible will go up, but if there's a lot more energy in the air and the temperature's gone up because there's more sunlight, or maybe the sun burned off the clouds and now there's intense sunlight hitting the ground, what other thing could start happening more and more? Well, evaporation could happen more. If there's more energy in the air and the sunlight's stronger or whatever's going on, if you've got more energy, you can evaporate water into the air, which will increase this part right here. So technically, if the temperature goes up, the maximum amount definitely will go up, but quite possibly the water present due to evaporation will go up too. So if temp increases, you will see the maximum possible amount go up, but also evaporation can increase, which will lead to the numerator going up, and RH stays the same. So that's one, and that's the other. Two different options here, and if you explain both of those, here's 1 point, here's an explanation for 2 points, here's your third point, and if you talk about evaporation happening and therefore putting more water into the air, that's your fourth point. Okay. So remember, we wrote these two, A and B, we put those on the board. We also talked about what would happen if just water present in the air increased and not the temperature, not this maximum amount possible, and that would increase your relative humidity. So you had to have both of these to get all 4 points. A lot of people rightly wrote A, but didn't have B. They forgot about the evaporation link, which is something that we put on the board a couple times. And this is where we have to make sure that when we're going over in class and I say, hey guys, this is a really good test question. This is something that most likely will end up on the test. And if it does, you need to have both of these answers. We got to make sure that we study not just the most obvious one, A, but that we're also remembering to write down B. I hope this helps with your corrections and getting ready for the test that'll be in a few weeks. Please let me know if you've got any other questions.